Hi, my name is Elizabeth, and I will be presenting my group's project titled Analyzing 21st Century Climate Data Across U.S. States with a special focus on Washington State. So when our group first met, we realized that we all had a shared passion for environmental justice and the fight against climate change. Because of this, we decided to look for data sets that would allow us to analyze climate patterns over time in the U.S., and more specifically, Washington. We were hoping by doing so, we could recognize patterns in temperature change, predict future change, and utilize our findings to educate others on the impacts of climate change. So our 5 research questions were, have any US states had a decrease in average summer temperatures from the year 2000 to 2021? Has there been a trend of an overall increase or decrease in precipitation across US states between the years 2000 and 2021? Which US states had the largest increase in winter precipitation from 2000 to 2021? Which US states have the largest increase in summer precipitation from 2000 to 2021? And what does the future of our precipitation rates look like in the winter season in King County, Washington? So for our methods for question 1 and 2, we used pandas to filter and modify our data set, and then matplotlib to plot all of our data and results. For question 3 and 4, we also used pandas to filter our data, and then plotly express to create choropleth maps of the United States based on summer and winter precipitation rates. For question 5, we used pandas and NumPy, matplotlib, and sklearn to filter the data and create and train the data sets, and then create linear regression models. So for the visualizations for question 1, our results from the filter data told us that there were 7 states with a decrease in average summer temperatures. So those are the ones that are plotted right here. So these 7 states were South Carolina, North Carolina, Georgia, Alabama, West Virginia, Virginia, and Tennessee. We graphed these results using a line plot, which shows the negative slopes of the 7 states when comparing their temperatures from 2000 to 2021. Then on the right, the graph shows overall temperatures in a scatter plot. We notice the temperatures have fluctuated greatly throughout the past 20 years and show an overall increase in temperature despite the few states that do have a decrease. Then for question 2, we have a graph showing the average precipitation rates from 2000 to 2021, where we saw a slight positive relationship between the increase in years and increase in precipitation rates. Usually, an indication of climate change is heavier rainfall, and even though the scatter plot isn't a clear indicator of this, we believe it's a result of using such a small time frame. So then our visualizations for question 3, we have the choropleth maps of the US based on winter precipitation rates in 2000 on the left versus 2021 on the right, where you can see there was a huge increase in precipitation rates in the winter in the West Coast states, especially Washington. Then for question 4, we have similar choropleth maps, but based on precipitation rates in the summer, where you can see the largest increase is in the southeast region of the United States. Then for question 5, we have 2 linear regression models that predict that future precipitation rates in King County are going to be around 12.5 inches in winter of 2030, 13.8 inches in winter of 2040, and around 15 inches in winter of 2050. So we see a steady increase in precipitation rates in King County, and based on our prediction, we will see a similar increase in the next 30 years. So next steps for our project would include integrating different data sets. We would probably want to include a data set that focuses on factors that affect climate change. This way we could create regression models to see which factors are having the largest impact, and then also compare those with our analysis of the locations of temperature change and precipitation rate changes. And then we would also want to take our analysis eventually to be used to either do further research or also just use it to predict to educate our peers on the impacts of climate change.